Hello everyone. So today we're going to look at chapter 8, radioactivity. And in particular, we're going to look at the first subtopic, 8.1, the history of the discovery of radioactivity. So we're going to look at how radioactivity was discovered and how it all began. So before we move on, let's look at the learning outcomes for today's lesson. We're only going to focus on one learning outcome for today's lesson, and it is the ability to describe the history of the discovery of radioactivity. In particular, we're going to look at the key players in the discovery of radioactivity, the first of which is Wilhelm Roentgen. The second person is Antoine Henri Becquerel, and the third couple actually are Marie and Pierre Curie. So we start our story with the discovery of X-rays by Wilhelm Conrad Roentgen. So that's him on the right side. And he was a prominent German physicist of the 19th century and was initially experimenting with cathode rays within vacuum tubes. Roentgen noticed that despite using a black cardboard material to block all visible light rays coming from the vacuum tube, there was a faint glow coming from a fluorescent material in the room that was 1 meter away. Now take a step back and think about this. You have cathode rays, which are essentially electrons being passed through within vacuum tubes. And despite blocking all visible light rays by using a black cardboard material, something was interacting with the fluorescent material, which was 1 meter away from the vacuum tube. And this was the big question. If all visible light has been blocked and does not reach the fluorescent material, what is interacting with it that is making it glow? So Roentgen continued experimenting with his X-rays and their penetrating power. In particular, he was trying to look at how far these X-rays could travel, as well as how much things they could penetrate through. He tested them with a pack of cards, thick books, and various other things. He found out that the denser the material, the more it would absorb these X-rays. To be more precise, the absorption of X-rays is roughly proportional to the atomic number to the power of 4. He continued his experimentation till he managed to get an image of his wife's hand in which he could see the bones, because these X-rays could penetrate the soft tissues but were absorbed by the bones. Now, let's take a step back and try to think about why is it that this happens. Well, if you consider bones, they are primarily made of calcium, which have an atomic number of 20. While on the other hand, soft tissues are primarily made of hydrogen, carbon, nitrogen, and oxygen. Carbon, which has an atomic number of 6, nitrogen atomic number of 7, and even hydrogen and oxygen all have an atomic number less than 20. So that is why bones absorb a lot more X-rays. And on the right side, we see the actual image that he managed to get of his wife's hand. But you also see a black bulge, and that black bulge is his wife Bertha's wedding ring that he probably gave to her. Now let's look at Antoine Henri Becquerel and the discovery of radioactivity. So there is Becquerel on the right side, and Becquerel was a prominent French physicist from a family of all physicists. His father was a physicist, his son is a physicist, and he himself is a physicist. And he had an interest in the study of fluorescence, which is the ability of certain objects to give off light, and was especially interested in X-rays, since X-rays could interact with the photographic plate. He tried using uranium, expecting to discover similar rays like X-rays, but found something entirely different and shocking. So, Becquerel actually conducted several different experiments using fluorescent uranium. So, the uranium on the right hand side, where it emitted light. But there was the non-fluorescent form of uranium in which it was not treated. However, for your information, uranium was formerly used in crockery because of its aesthetics. This was before people knew it was radioactive. And Becquerel conducted experiments on uranium, which was a highly fluorescent material, to see if it was just like the X-rays. So he tested to see whether the fluorescent uranium actually reacted with photographic plates, and lo and behold, it did. However, one day, Becquerel left a non-fluorescent sample of uranium next to a photographic plate in a dark room. What do you think happened then? Remember, this is a non-fluorescent sample of uranium. Do you think it's still gonna react with the photographic plate? Let's find out. When he came back, it had reacted with the photographic plate, and this was an utter shock. What was going on here? Becquerel thought that it was the fluorescence that was from uranium that was reacting with the photographic plates and not something else. But the fact that the non-fluorescent sample of uranium reacted with the photographic plate gave him a conclusion. And the conclusion was that the photographic plate was not reacting to the fluorescence, but something else within the uranium sample. And finally, we introduce the biggest power couple, biggest player in this whole story of radioactivity, Madame Marie Sklodowska-Curie and Pierre Curie, both husband and wife, both working on the same thing. So chemists at the time believed that there was nothing else to be discovered and were content with the periodic table as being absolute and unchanging. So they believed that there was nothing or no such thing as transmutation. But everything changed when Madame Curie had appeared with her groundbreaking research, which challenged not only scientific norms, but as well as the uproar against female scientists at the time. She had escaped from Poland, which at the time was removed from the map because it was conquered by Russia, and moved to Paris to pursue her studies. Although Becquerel had discovered radioactivity, he encountered radioactivity, he did not coin the term radioactivity because he quickly dismissed it and did not do any further work on it. The scientific community at the time were more interested in studying X-rays. Madame Curie realized this and leapt at this opportunity and made it her graduate study research to actually study what Becquerel had left behind. One of the things that attracted Madame Curie to the study was the fact that uranium had the property of charging the air, that is, creating a charged field around it. Now, let's look at a study of radioactivity by Madame Curie. So Madame Curie used a device that could make accurate measurements of what is now known as activity of the sample. So how active is the sample in terms of its radioactivity? Using the device, she studied the activity of pure uranium samples and tried many other elements, but initially found only uranium to have any effect. That is, to have the ability to charge the field or the air around, which is normally a poor conductor. So air is a poor conductor, but when uranium was around, it was able to charge the air. She thought it was a property only specific to uranium until she measured an element called thorium, which showed an activity level much higher than uranium, much, much higher than uranium. And this was a big, big, big discovery. She measured a material called pitchblende, now known as uraninite, which was the impure ore of uranium. It turned out to be 4 times more radioactive than pure uranium. Remember, before this, we were looking at pure uranium. Now we are looking at pitchblende, which is the form of the ore in which uranium comes from. And this was 4 times more radioactive than pure uranium. It was through much arduous work that Madame Curie and Pierre Curie realized that there were other new elements within pitchblende, because by refining pitchblende into separate components, into components that were radioactive and that were non-radioactive, they ended up with 2 different elements, and these 2 new elements were called polonium and radium. So polonium and radium. She was awarded the 1903 Nobel Prize in Physics along with Henri Becquerel and Pierre Curie, her husband. Although these discoveries may look simple, but let me tell you a little bit about radium. Within pitchblende, radium is a very, very small amount containing within pitchblende. And to extract radium from pitchblende, Madame Curie had to get 10 tons of pitchblende, which is 10,000 kilograms of pitchblende, to get 1/10 of a gram of radium. And it took her 4 years just to harvest that amount of radium. Try to imagine the amount of work that was put into just to create 1/10 of a gram of radium. Wait, so is that all then? Is that everything to the story of radioactivity? One day, as Mary and Pierre Curie were visiting their lab at night, they noticed that their vials were glowing. And the question that straight came to their mind is, if light is known as a form of energy, where is all that energy coming from? So, to all my viewers who are watching this presentation today, I officially welcome you to the study of radioactivity. Marie Curie, thinking fast, immediately proposed something so preposterous to the whole scientific community. She proposed that a form of transmutation was occurring. Now, what is transmutation? So transmutation here means that, for example, radium was changing into different elements through a certain process. How can one element change to something else? Another question that popped in their mind is, well, if transmutation was occurring and if elements were changing, then there must be more towards the atom. Is the atom an indivisible ball, like Dalton's atomic theory? Or is there small particles within the atom? So this was the question that was raised just by this observation that Marie and Pierre Curie had observed. So let's test yourself. Could you name the person who discovered the X-rays? Pause the video if you need some time and give an answer. So it was Wilhelm Roentgen. Could you name the person who discovered the radioactive radiation? It was Henri Becquerel. What about the gamma rays emitted by radium? Madame Curie and Pierre Curie. Second question. what are the names of the two radioactive elements discovered by Madame Curie and Pierre Curie? Do you still remember them? One is really hard to process if you remember them. So one is polonium and the other is radium. And for your information, polonium was named after Poland by Madame Curie as a tribute to her original country, which was taken away by Russia. So that is all for me today. I hope you've enjoyed the video, and I hope you're able to gain something out of the video today. Please take care of yourself, and thank you once again.